Why pollen quality matters. As you can see, there is no punctuation mark in the title. If you don't know why pollen quality matters, you put a question mark. If you know why pollen quality matters, like our customers and we at Amphasys, you will put an exclamation mark because you know it is important, it matters. So I will do what, I will continue what my predecessors said in the morning sessions, and I will show you some examples why pollen quality matters. Imagine you are a breeder, and normally you are looking for new traits, and we learned that high yield or increase of yield is the most important, but of course you have always new varieties, new colors, better taste, disease resistance, of course, all important things. But you don't necessarily pay attention to the quality of pollen in breeding, although pollen is the main matter that transports the genetic information. And do you think you should neglect this carrier, the quality of the carrier? In seed production, you try to control and optimize everything to obtain a full seed set. You control temperature, if possible, soil moisture, nutrients, again, diseases. But if you don't pay attention to the quality of pollen, you will not obtain the full seed set, because pollen is one of the most important matters that ensures high seed set. You will ask the question why pollen quality matters if you have never systematically measured pollen quality, because you don't know perhaps that it is easy to easily screen lines, that you easily can measure pollen quality, that you don't have to do staining or germination assays. Or if you don't know which relevant information pollen quality measurements can bring and which economical impact they have on your result. If you doubt, why do you think that 15 of the top 20 global seed companies rely on our technology? Because pollen quality monitoring has impacts on breeding and seed production, and therefore on the economic success of your operation. And this is what I want to show you in some examples. Let's start at the beginning with your early steps. What do you think is the economical impact of pollen quality monitoring in research and breeding? You reduce time to market, you can reduce costs of your operations, and you can increase the efficiency of your breeding process. So I will show you some examples and case studies. I guess you all have seen pollen cells under the microscope, and in this case, it will look, the germination assay will look like that. You find the viable pollen cells, they are forming the pollen tube. The dead cells, they stay dead, they do nothing. And then you have a third population, a third group of cells, the aberrant cells. They are often neglected in germination assays because these are small, shrunken cells. But if you neglect them, then you won't get the right result, because they give you also information. Germination assays is tedious work, and Jan talked in the morning about staining assays. So it is a lot of work. The results are more or less good. So this is how you see pollen with our technology. And I don't want to go into detail, just to mention that every single blue dot is one pollen cell. And we are measuring here thousands and 10,000s of cells. So the good thing about our technology is that it automatically gives you the result. So at the end, you will quickly see after the measurement what is your amount of viable cells, your amount of dead cells, and also the amount of aberrant cells. In addition, you will see the total number of cells measured and also the concentration. So this method gives you a very fast and immediately an immediate result. It is not user biased. It is completely location independent. And due to the high number of cells, what we measure, it gives you a high statistical accuracy. So therefore, it is a method for routine measurements and systematical screening. Double haploid production is gaining interest, or has gained already a lot of interest, as it shortens breeding significantly, and it shifts activities from the field to the lab. But here again, you need the appropriate starting material. And this requires microspores in the right developmental stage, preferentially in the late uninucleate stage. As you can see from this wheat spike, this is not yet mature, so that would be the starting material where you start from. And you can see that there is a distribution of different microspore developmental stages along the spike. And to identify which is the right starting material, this technology helps you to easily identify where is the best material. In this case, you will find it in the bottom of the spike, where you have 100% uninucleate material. This is how you would see it with our technology, and I don't want to go into detail, and you don't need to be an expert with our technology, but what you can see easily is for every stage, different microspore developmental stage, you have a completely different pattern. So it is easy to identify where would be the right stage in order to start with, to start your induction and to have a high probability for the formation of embryos. So if you can increase the probability for embryo formation, you can also increase the efficiency of your process. Let's go to the breeding. In this case, you see 30 lines of broccoli, all grown under the same conditions. What we have displayed here is the percentage of viable cells, which are the purple columns, and the amount of aberrant cells, which are the green lines. And you can see among these 30 lines, there is a large variety. They all behave completely different. And by the way, the measurement of these 30 lines would not even take you 2 hours. So this is really a fast method in order to screen your lines. So if you do this systematic screening, it will show you which are the good pollinator lines and which are the lines which are perhaps more susceptible to abiotic stresses. So these lines here, they show a very high amount of viable cells and at the same time a very low amount of aberrant cells. That would be good pollinator lines. In contrast, here you see bad pollinator lines, because they don't have a high viability, and even in some cases, the amount of aberrant cells is higher than that of the viable cells. So if you continue with these lines, it will create problems in seed production, and the seed production manager will not be your friend anymore. So the faster you get a full set of information about your lines regarding the pollen quality, the better it is for the subsequent processes to know with which lines to continue. And then you avoid costly breeding and seed production processes. We were talking this morning already about when is the right time to measure the pollen quality of the lines. And of course, you can screen in any generation, but you should know about the quality of your parental lines. And then, and I think it was mentioned by you as well, you should screen again in the generation 5 or 6 after selfing when a certain level of homozygosity is reached. And then you can compare the sibling lines and select those with the best pollen quality and low amount of aberrant cells for further continuation in the breeding. So with the selection of good pollinator lines, you can reduce the likelihood of issues further in seed production. And this selection saves time and resources, but it helps also to get faster to market. Let's go to production research and seed production. Here you need to develop the best production method, and it is all about cost and efficiency, but also reliability is an issue, as you want to reach your production target and not overreach it as well. And pollen quality measurements can help you to reach these targets. If you're a seed producer, you don't want a high inventory of seed, but neither underperform your targets. To control the seed production process in the best way reduces uncertainty and increases reliability. Crop placement, and we heard that in the morning already, plays therefore an important role to put the right lines in the right place. In this example, you see 3 different lines in 2 different locations and how they behave differently. In contrast to normal figures where we show the concentration of viable cells, in this case, on the y-axis, you see the number of viable cells. That means we have run measurements of pollen viability and separately determination of the pollen quantity. And we have combined these results in order to get the number of viable cells. Line 1, the purple column, shows clearly preference for the colder area. Location 1 is the colder area. Location 2, the warmer area. So you see that in the warmer area, only half of the amount of viable cells is produced than in the colder area. Line 2 is nearly unaffected by the different environmental conditions. And line 3 also shows a high amount of viable cells in the cold area, in the colder area, and somewhat lower extent in the warmer area. But even though it's only perhaps 10%, this makes a big difference on your result. So the information on how your lines behave under various conditions regarding pollen quality helps you also in crop placement to increase the reliability of your operations. One possibility to increase reliability in seed production and to improve the benefit is to establish a correlation between viability and seed set. If you know your pollen viability and the resulting seed set, you can better align planning and get a more stable seed production. Therefore, there is a considerable interest to establish this correlation between pollen viability and seed set. Normally, we assume that in this case, this line has a natural range of viability between 50 and 90%. In order to get a correlation between pollen viability and seed set, you need a larger range. So we have artificially extended the range of pollen viability by creating these viabilities up to 0. And after pollination and after obtaining the result regarding the seeds per fruit, we get the correlation. And these are the artificially created viability numbers. So if you want to obtain 90 seeds per fruit, you know with this correlation that your pollen viability should be an average 70%. Or if you know that your lines have an average pollen viability of 70%, then you know that you can calculate an average 90 seeds per fruit. So establishing a pollen viability seed set correlation guarantees you a more stable seed production. Routine measurements of pollen quality are important if there is a whole pollen supply chain, where pollen is grown, harvested, stored, and transported before pollination. So, for example, in pollen farms, what we discussed already this morning. And as the pollen quality can only decrease, it is important to control this supply chain. The development of storage protocols is particularly important. And to assure that you don't lose viability over time, the establishment of the right protocol as well as the quality control over the whole process is important and indispensable. So with the right protocol and routine quality control, you can prevent the loss of precious material, because this is what will happen. This example shows how you can improve the efficiency in seed production with the support of pollen information. Seed production in greenhouses is particularly expensive, so the cost of space, of surface is really high. And you only can earn money with your female lines. So if you want to be more efficient, you should reduce the surface of your male lines. If we assume that we are talking about a surface of 10 hectares and you have planted 8 hectares of female and 2 of male, you have a female to male ratio of 4:1. If we now decrease the surface of the male lines by 25%, which is about 0.5 hectares, and increase it for the females accordingly, then you get to a female to male ratio of 6:1. So this would be in one season. Jan has brought the example over 3 seasons and came up to a female to male ratio of 9:1, which is even more interesting. But the thing is the same. So if we now assume that in this case, you can increase the seed production by 50 kilogram on this additional 0.5 hectare, and the seed price is only $1,000 per kilo, your benefit is $50,000 just in that one season. All these examples show that it is important to gather information about your lines regarding pollen quality, and that it is fast and easy to obtain this information. So systematic screening and routine quality control of pollen is easily possible. If you know your lines, you have a better control of your processes and planning. You can save costs and resources and achieve higher efficiency and yield. And this is why pollen quality matters. Thank you.